6.5, we're going to talk about average value of a function. First, going to ask you this question. Okay, suppose we have 3 tests. Test 1, 2, 3, right? And how do you find the test average?
You add
add all of them?
Yeah, you add all of
divide?
them, right?
And then divide by the number of tests.
Yes, and then divide by the number of tests. Okay, got it. So now then you add them up, and then you divide by the number of tests, which is going to be 3 tests, right? So divide by 3. Similarly, if you try to find the average y value and you have n of them, you add them up and then you divide by n. Now, over here, we have, this is a graph of the temperature of the day. So from midnight and then 24 hours from then, okay? And then this is the graph for the temperature of the day. So the temperature drop and then later on rise and then later on go back to this. Okay, so this is the graph of the temperature function for one day, and that's F. So how can I find the average temperature of the day? And let's call the F AVE here for average. So the average temperature of the day here, how can I find the average temperature of the day given this graph right here, given this function, the temperature function? The idea is this: if you have like n, y coordinate, and then we just add them up and divide by n, right? So how about we can take some sample, okay? So I can take some sample, maybe I can take 4 sample, okay? So during the day, I can take the temperature over here, 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 and here. And I look at the temperature, and then I can add them up and divide by the number of reading, right? Okay. So I can take n of them. For example, I'm going to divide this time from 0 to 24 hour here into subinterval. So each one here is going to be, the length of each subinterval will be 6 hours. And then in this 6 hour, and I'm going to take a reading. So I take this sample point here. So x1 is a time within the first 6 hours. x2 star is a time within from 6 hours to 12 hours, etc. So you take a time. So those are the sample points. So the idea here is we divide this interval here into n subinterval. So over here, I divide into 4 subinterval. And then each one with equal width, delta x. So for example, in here, the width for subinterval here will be 6. It's 24 divided by 4 because I divide that into 4 subinterval. So the delta x here is the width. Now, if I divide this a to b into n subinterval, what will be delta x in terms of a and b? Can someone tell me?
B minus a over a.
Yeah, it's b minus a. That's the length for the from 0 to 24 here. So it will be b minus a. So that's the length for this interval. And then because we divide that into n subinterval, so you're going to divide this length here by n. Okay, so divide that by n. Okay, and then we choose point, sample point. Okay, x1 star, x2 star. Think about the star there. Okay, don't be intimidated by the symbol. The star here basically just means it's an arbitrary point in this subinterval. Okay, so x1 star is an arbitrary point in the first subinterval. x2 star is an arbitrary x in this second subinterval. Okay, etc. And then we can calculate. We can calculate the average by doing this. So x1 star here, the y coordinate, the corresponding point on this curve is this point right here. We look at the y coordinate at this point, which is the function value at this point. That would be f of x1 star. And then similarly, we do over here for x at this time, okay, x2 star. We look at the function value. So that's f of x2 star, etc. And then this one here will be x of x4 star. The function value will be the f of x4 star, okay, etc. So what we do here is we're going to add them up. So we add them up, and then we're going to divide by n. okay, because we have this n reading over here. Now we can use this to approximate the average value of the function in this from 0 to 24 hours. So to represent this, we can use this sigma notation. A short notation for this sum over here is this sigma notation. How does the sigma notation work? The sigma notation work like this. Now, all of this over here, they all similar, except the index here change. 1, 2, 3, 4, and then all the way to n. So over here, we put f of x, xi star, and then the sum here, this is the summation sign, okay? So the sigma notation is summation sign. So you add up s f of x1 star, and then f of x2 star, etc. Now the I here is the index. It starts from 1 and ended at n. So I put down over here. I go from 1. I start from 1 and ended at n. So the starting index here, the ending index over here. Every time it increases by 1. So 1 and then 2 and then 3, etc. All the way until which n. So what this means here is this. This sigma notation means f of x1 star plus f of x2 star plus f of x3 star, etc. All the way to add to f of xn star. So that's the short notation for this sum over here. And then divide by n. Now we're trying to come up with an integral. Let's try to represent this n over here with something with delta x. Okay, with this delta x over here. So later on we can relate that and try to use an integral. Okay. So how can I represent this n here using delta x? They are related over here, right? Delta x and n are related this way. So
b minus a over delta x?
Yes, that will be b minus a over delta x, right? If you solve for n over here, that will be b minus a over delta x. Okay, good. So that's b minus a over n. And if you solve for n, so that will be b minus a over delta x. And now we can replace this n here by b minus a over delta x. So replace this n here by b minus a over delta x. Now let's simplify it. Notice that the 1 over b minus a is a constant multiple. It doesn't change as this index here change. So I'm going to bring this 1 over b minus a in front of the sigma, okay, in front of this sum. So bring 1 over b minus a in front. Okay, so bring this 1 over b minus a, this constant multiple in front of this sigma. Now we're going to let this n over here increase. So instead of like having only 4 reading, I can have 24 reading. I can have reading every 1 hour, right? And then I can actually have a reading every 5 minutes, okay, if you want. Okay, and maybe every second. So you let n go to infinity. The more reading, the more frequent you take the reading, the more reading you will have. Then the average that you calculate this way is getting closer and closer to the average of the function value, the average temperature of the day, right? The more frequent you take the reading, the more reading you read, right? Okay, so that's the idea. So you let n increase, which means you divide the time over here into more and more subinterval, each will equal with. So let n increase, okay? So we take more frequently the reading and take more reading, okay? So we take the limit of this expression right here. So this is the Riemann sum. The limit of this Riemann sum corresponds to an integral. And what integral does it correspond to? Can someone tell me? As n goes to infinity will be an integral. What integral I should put over here?
b minus a.
Okay, 1 over b minus a. Okay, so this part doesn't change. 1 over b minus a. This Riemann sum over here, as n goes to infinity, become this definite integral. Okay, that definite integral over here will replace this xi star by what? By x. And then the delta x here replaced by dx. X go from where to where? Well, x go from the starting x here is a, the ending x is b. X go from a to b. So we just discovered that the average value of a function on a to b is going to be this. So this stands for the average value of the function f, and that's equal to this definite integral, okay, the integral of this function f from a to b, and then times 1 over b minus a, or in other words, it's going to be divided by b minus a. Let's try to interpret this, okay? So it's going to be the integral of this function, integral of the function f, and x go from a to b, and then divide by b minus a. And that's how you find the average value of the function f on the interval a to b. So one way to, if you want to visualize it, okay, you can try to think about this one. If this is a positive function, okay, or if it's just a function, any continuous function, okay, so this part here, remember our area formula, right? So this integral corresponds to the net area under the function f. So if it's a positive function, you can think about it as the area under the curve. Okay, and the b minus a is the length of the interval. So if you try to find the average of this function f on this interval a to b, so what you do here is you find this net area, and then you divide by the length of this interval b minus a. Then you get the average of the function, which makes sense, right? Think about that. If it's a rectangle, if it's a constant function, then will be the rectangle divided by the length here. That will be the height of this, which is the average, right? Okay. If it's if the function is a constant function. Okay, now we have this function, f of x equal to 1 plus x squared on this interval -1 to 2. Let's find the average value of this function. So, anyone? What will be, what should I put on top as the numerator? Remember, it's the net area, right? What's the net area of this function? Integral of what?
-1 to 2.
Oh, okay. So you just said that the lower limit is -1 and then the upper limit is 2, okay? And integrate this function, right? 1 plus x squared dx. So it's the integral of this function from -1 to 2. Okay, so that's the net area. Divide by the length. The length here it is 2 minus
-1.
-1,
It's 3.
which is 3. Yes, you got it. Okay, so that is 3. Now we just need to find this integral over here. So this integral will find antiderivative. So antiderivative, what would that be? What's the antiderivative?
X plus x
cubed divided by 3.
Yes, you got it. So it is x plus x cubed over 3. Yes. And then we're going to evaluate this from -1 to 2. And if you do the calculation, that will be 2. Now, to help you visualize it, I graph this function, 1 plus x squared over here. This is a graph. Okay, here for this -1, here's 2. I find the average value of this function on -1 to 2 is equal to 2, over here. Okay, so what does it mean? So that's the average on value of the function on -1 to 2. You can try to think about it. If I chop this one, cut that along this horizontal line, this part that's above this line right here, this area, I can actually cut it and fill over here. It's going to fill in this gap here. So the area under the curve is actually the same as this area of this rectangle over here. So cut this part, you can fill over here. This horizontal line here, the equation is y equal to 2. Are you guys okay? Question? Okay, now mean value thing from 110a. Okay, I don't know if you guys remember. Okay, so what does it say? It says that if the function has satisfied these two hypotheses, so it's continue on this closed interval a to b and differentiable on this open interval a to b, then there exists a number c in this open interval a to b, such that what happened? Such that what happened here is the slope of this tangent at this c is equal to the slope of this secant line AB. So what's the slope of this tangent line at c? Well, slope of the tangent corresponds to the first derivative of the function. So it's f prime of c. So that's f prime of c right here. So what about the slope of AB? What's the slope of this secant line AB? Use the slope formula. So that will be what? F of Well, y2 will be what? Yes, y2 will be FB, y1 will be FA, right? Okay, so you will have this y2 minus y1, so FB minus FA, over x2 minus x1, so over B minus A. That's the slope for this AB, okay? So these two are equal. Now, another way to put this is you can multiply both sides by B minus A. So now you're going to have FB minus FA equal to F prime of C times B minus A. Okay, so that's another way to write this result of this mean value theorem. If you try to Google mean value theorem Beijing, okay, see what you find. So if you Google, you find this image. So Beijing is the capital city of China. If you Google that, you'll see this photo. Okay, what do you see on the bridge right here? Now this photo is taken that, let me read this to you, okay? The government of Beijing celebrate the mean value theorem. The picture is taken a few blocks south of Tiananmen Square. Tiananmen Square is kind of like the White House over here in America. Is that right? So it's so important. They actually celebrate that. Okay. And what do? They put it on this bridge. Okay. They put it on the bridge. Okay. Can you guys read this? What does it say? FB minus FA equal to F prime of, they put sigma over here. You can actually put C, F prime of sigma or C, parenthesis, B minus A. That is our mean value theorem. For those people who are in my 110A class, I hope you remember this. I showed that to you before, right? The mean value theorem is actually, I think it's appropriate to put on the bridge. Okay. Let me help you to remember this. Now imagine this is the bridge, right? The two endpoints might not be at the same level. Maybe one is higher, one is lower, right? And then this bridge over here. And then when you walk along the bridge over here, okay? So this is a continuous curve. It's also differentiable, okay? Now, when you walk along this bridge, somewhere along this bridge, your direction of walking is going to parallel to the base of the bridge. Next time when you walk across the bridge, you try to think about the mean value thing. Okay, so the direction is going to be parallel to this, the base of the bridge. Isn't that? Have you seen this? Do you know that?
I'm imagining it in my head right now. It makes sense.
I mean, imagine. Oh, that's good. Have you seen other countries put a map theme on the bridge?
Oh well, in Japan, there's this bridge that looks like that. The Gojo Bridge, I think, or something. That's something what it's called.
They put some map equation on the bridge.
Oh no! But it's it looks really similar to like the drawing, like the bridge shape.
Oh, the bridge. Okay, the bridge.
Yeah.
But putting math equation and theme on the bridge, this is kind of interesting, you know. I wonder if you can find the other place. Actually, not just this one. Guess what's on the other side? E equal to MC square on the other side.
Oh my god, I guessed that, but I didn't say it.
The other side. Yeah, okay. So share this with you guys. Okay. So that was a mean value theme. Okay. That's the mean value theme for function. Okay. Now today we have the mean value theme for integral. So the mean value theme for integral today it says like this. If the function is continuous, the function here is continuous on this closed interval a to b, then there exists a number c in a to b such that the function value at c is equal to the average value of the function on this interval a to b. So f of c will be equal to f average. You understand? So somewhere in between, this function value is equal to the average value of the function. Now we know the average value of the function. We just found the formula, which is what? Everyone? 1 over what?
B minus A.
B minus A. Okay, B minus A. And this integral of the function. So integral of the function, okay, f of x. Found that. The average value of the function is the integral of the function from a to b, and then divide by b minus a, right? Another way to write this result here, you can multiply both sides by b minus a. So this is going to become, so when you integrate this function from a to b, they'll be equal to b minus a times this fc. notice that this integral over here, how do you find this integral? This integral over here, this is actually related to the mean value theorem for functions, okay? Because this integral over here is actually, remember how we find integral, right? We find antiderivative this small function f. Let's call one of the antiderivative this small function f. Let's call it big F. So we have big F function divided at b, and then subtracting this antiderivative evaluate at a. So now this function small f here is a derivative of the big F function. So it's kind of like, it's like the mean value theorem for functions. Okay, so they are related. Okay, now get to this. So this function 1 over x, okay, is continuous and differentiable on 1 to 3. Okay, we try to find c. So by the mean value theorem, there is a number c here between 1 to 3, such that the function value will be equal to the average function value on this interval 1 to 3. So let's find the c over here.
To find the average
so what
value,
is the c?
so
So
what
how
do
do
we
we do this? Any idea?
Now, to find this average value, what do we do?
We set this up. Okay, it's an integral of the function
Integral 3 to 1, right? And then you do the
1 to 3. Yes, you got it.
yeah
And then divide by
1 over x divided by b
by
minus a, 3 minus 1. So yeah,
right. Very good. Now that's equal to what's an antiderivative 1 over x?
shoot, wait,
ln of x.
yeah, there we
Okay.
go. Brain stutter, yeah, ln of x over
But
2.
don't forget
Over
the
2.
absolute value. Okay.
Yeah.
Yeah. Don't forget the absolute value. Now we're going to evaluate this. X go from 1 to
3
Yes.
Yeah.
times 1/2.
Yeah. Divide by 2. Okay. So that will be ln of 3 subtract ln of 1 over 2. And that's equal to, what's ln of 1?
0.
ln of 1 is 0.
Yeah, it's 0. So that's equal to ln of 3 over 2. So that's the average value of the function on this interval 1 to 3. Now we're trying to find this c here, such that the function value equal to this, ln of 3 over 2. Okay, so how do we find this? Well, we can substitute c. Replace this x here by c. So this will be 1 over c. And set that equal to ln of 3 over 2. Solving for c, what does c equal to? This is the reciprocal, right? 1 over c is this. Then you would take reciprocal this. So that will be 2 over ln of 3. So if you take reciprocal, okay. So 2 over ln of 3. Okay. So over here, when c is equal to this, then the function value will be equal to this, which is the average value of the function. So you found the c. So in your homework, you're going to be asked to do something like this. Find the c. Okay. So that's the end of our lesson today.